So as Sandy mentioned, I'm Nathan Schaepe. I'm with the US Geological Survey, the Nebraska Water Science Center. We're based out of Lincoln, Nebraska. I've presented a couple times for MSAC in the past. And so I'm going to talk about a study that we're going to be starting this year and some other USGS data that's available related to the 2019 flood. I'm sure most of us, well, I'm sure anybody that's attending this meeting is well aware of the flood of 2019 last year. And so I kind of wanted to, just to kind of give you a preview, I want to talk a little bit about that and then a little bit about the study. But I mainly wanted to have a large amount of time for questions related to just any studies that we have going on or USGS data related to the flood. And I'm probably not going to have all the answers, but I will do my best to find them and provide them to Sandy, or I can provide my contact information for anybody who wants to contact me directly. So without any more further ado, try sharing my screen here. All right, hopefully everyone can see a picture of Google Earth now. So what I'm focused on, or what I want to talk about, is the Niobrara River flood. And that all started So we have, hopefully you can see the picture here. So this is what Spencer Dam looked like prior to the flood. So it's just a small hydroelectric dam. It's been around for basically 100 years, I believe. And it didn't store a whole lot of water. But actually, I was pretty familiar with this particular dam. I worked with the Corps on studying how much sediment was released. So in years past, the sediment would, because there was a small amount of storage in this particular reservoir, it would fill with sand pretty regularly. And so they had to flush all that sand out about once a year, or actually, I think they did it normally twice a year. But when we were studying it, they were just doing a one-year release because they can only release it during certain flow conditions, and that year didn't allow for 2 of them. So that's what it used to look like. And then this is what it looks like now. Total destruction. And what happened, there's actually been a report released that looked at exactly what led to this. And basically the force of the ice broke open gates. But the bigger issue was there's a levee on this side that broke open and all the water went out. This is the south, this is on the south side, and all the water, most of the water came through there. And eventually the gates themselves broke open and water went all over the place. For those who aren't familiar with that particular area, let's see if I can zoom in to Google Earth and show you. So this is Highway 281 north of O'Neill. And so this is where the dam is. You can see in reference. So from there, and here's Lewis and Clark Lake down this way. So it's quite a long distance, but at our gauge at Verdell, which is right about here, when that happened, there was a 13-foot rise at our gauge there. So it was a lot of water coming through. By the time it reached Niobrara, had the rise wasn't quite as severe. It was about, I believe it was about 6 feet, but still the water was so high even before that that it caused mass destruction, especially with all the ice. And as I mentioned, so we collected a lot of data after the flood and during the flood. One of the things I wanted to make everyone that's at this meeting aware of is our flood event viewer. So to get to this, it's really easy. You just type USGS flood event viewer, and you're just with Google. It allows you to select an event. And so for last year's event, you would just select Central US Spring 2019. And all these little dots here, a lot of them are high water marks from our flood. Well, not just the Niobrara flood, but as everyone knows, this was pretty extensive flooding throughout Nebraska and South Dakota, Missouri. So USGS, along with several partners, like the Corps of Engineers, some of the natural resource districts, helped identify high water marks. And so you can see over here that there's these different icons that you can click on. So I'm taking you into the town of Niobrara, and these little diamonds, let's see over here in the legend that says high water mark. And it gives you an elevation of how high the flood reached. And if you click on this high water mark data page, you can actually see where these high water marks came from. This one's kind of hard to see, but so what high water marks are, you find a debris line that's left behind. So you can actually see a little bit of mud or dirt that's left behind. You can kind of see it here. And then that point is marked, and those points are surveyed in to determine how high the water got. So, and then also you can look at stream gauges. That's what these black triangles are, and this peak summary gives you an estimated peak elevation that the river achieved during that time and when it occurred. So I think a lot of you might be interested in that. So that's what happened during the flood. So that leads me to the study that I'm involved in now. And so this study is with the, let me stop sharing my screen real quick. So this study is with the Natural Resources Preservation Program through, it's a USGS and National Park Service partnership. And so it's going to be focused on the Missouri National Recreational River. And I need to specify that we're looking specifically at the 39-mile reach. For those that aren't familiar with that. So this red outline is what is included in the 39-mile reach. So it also includes a substantial part of the lower Niobrara, as well as a little bit of Verdigris Creek. So this study is to look at how this area was affected by the flood that was caused by the Spencer Dam failure. And so because this is specifically National Park Service well, the work is related specifically to the National Park Service needs. We're going to be looking mainly at habitat. But I know that a lot of the data that we've find from this could be useful in for other things too, especially specifically to MSAC, looking at you know, how much sediment has moved downstream, and is that sediment continuing to move downstream, or is it being stored in different areas, that kind of thing. And so one of the big parts of this study is going to be looking at these what are called the sediment aggregation range lines that the Army Corps of Engineers has been surveying for, I believe, since the 1960s, maybe even before that. But that's what these black lines are. And so they actually, Paul Boyd and some of Paul Boyd's team surveyed a lot of these lines back actually at the end of 2019, I believe in August or September. So part of the study is I'm going to look at what that data tells me. There's also some FEMA aerial imagery of the Niobrara River. And I'm going to try to determine areas that received a lot of sediment. And we're going to resurvey those and see how much sediment is accruing, if there's been additional sediment deposition, if a lot of that sediment is eroded away. But because this study is focused on habitat, we're going to be focusing in on a lot of the pools, a lot of so the terns and plovers are they need bare sandbars. So we're going to look at if there's new sandbar creation, if old sandbars were eroded away, and that kind of thing. But once we determine, so this summer we're going to be looking over a lot of the data, looking at the surveys that the Corps has, like I said, looking at aerial imagery, and then we're going to resurvey a lot of these areas. And we're also going to be looking at, so the Spencer Dam Reservoir had a lot of sediments that were moved downstream potentially. And with anytime you have historic sediment, there could be organic contaminants contained within that. So we're going to be doing some organic contaminant analysis of the sediments, and how you do that is you determine what sediments were deposited during the flood, and you take a core basically and you send that in and have that analyzed. So this is going to be a 3-year study. Like I said, we're just starting it this year. This year and next year will be data collection, and we'll be putting out a report in the 3rd year. And so that covers that, a little bit about that study. I was at an MSAC meeting last summer, and I mentioned that we were going to be doing some what's called topobathymetric LIDAR, which is basically flying over an area and trying to get elevations of the river bottom. For those that aren't familiar with what LIDAR is, I have a little bit of a description of that. So, oops. So this is kind of a basic picture of what LIDAR is. You fly a plane and it shoots pulses of light, and it measures how long it takes those pulses to return to the plane, and gives you elevations. And this is a quick way to get very accurate data. You can get data that's 10 to 15 centimeters, or like less than half a foot accuracy in elevation accuracy. And then what topo LIDAR is, or I should say topobathymetric LIDAR is where, so we use a different kind of light frequency, and you can actually, normal LIDAR will ping off the water surface. Well, if you use a different frequency, you can actually get through the water itself and you can get elevations of the bed. And so we have planned to do that throughout most of the Niobrara River. But last summer, the water was still too turbid. It requires a certain limit, a minimum. You can't, the turbidity can't be generally above 10 NTUs for those familiar with turbidity units. But we're talking about trying it, even if it's a little bit higher than that. So like I said, we weren't able to do it last summer, but it's scheduled for August of this year again. But with the water still being higher, we don't know what the turbidity is going to look like. So it's possible that won't happen. But I just wanted to give an update on that and let people know that hopefully we will have that, because that would save a lot of time for this year's surveying, because we could do less on the ground surveys and mainly do control points. So I think that covers most of what I wanted to talk about as far as the work coming up. So I'm going to stop sharing my screen and open it up for questions.
Oops. Okay, we did have one question come in. Will you be looking at grain size distribution of the sediment as you move downstream from the Spencer Dam? And how deep into the river can you see with the topo LiDAR?
As far as the grain size, yes, we're planning to do some grain size distribution analysis. And I know, when we did the flush study a few years ago, I'm curious to see what that shows, because in the flush study, we saw the most of the sediment during the flushes deposited within like half a mile generally. And then, obviously during the year it was moving downstream. But because of this large event, I'm assuming a lot of that sediment, made its way all the way down to the Missouri, almost not instantaneously, but pretty quickly. So my hypothesis would be that the grain sizes would be pretty similar downstream to upstream. But yes, that is something we're looking at. And then as far as how deep, it really depends on turbidity. I mean, from what I've been told, I think, they've done it in rivers as deep as 20 feet, I believe. Don't quote me on that, but I can get an exact answer too. I'm not responsible for the LiDAR portion of our work. One of my colleagues, Brenda Densmore, handles that, and I can find that out from her. It definitely works better in shallow rivers, but it's been done in some deeper rivers too. That picture that I showed you is actually from the Delaware River. And yes, I will share my contact info. I don't know, Sandy, should I just have you send that out, or I don't know what the easiest way to?
Yep, we can sure do that.
I'll have to get you my cell phone, seeing as how I work out of my basement these days, and I'm pretty sure the only number you have is my office number.
Probably, yep. Let's see. Okay. Okay, let's see, we've got, does anyone have some questions? There's plenty of time here. I don't know, it looks like I guess one thing that MSAC has said a lot over the past many years is that, well, the Niobrara River is the largest contributor of sediment to Lewis and Clark Lake. anywhere up to 60% of the sediment that enters the reservoir, it appears, comes from the Niobrara River. So I mean, we are interested in seeing how the flooding last year has impacted that. And we realize that your study is focused more on the impact to habitat for species on the National Recreational River. I guess, do you feel that some of that information may come to light as to how the rates have changed or possibly changed?
Yeah, and as I mentioned, the Corps did, and I saw something from Paul said that they're hoping to get some additional funding this year to resurvey the lines. That's good to know. I'll have to keep in contact so we're not duplicating each other's work. But yeah, you know, like I said, we're going to be surveying a lot of these areas, and I'm going to try to, a lot of the lines a lot of the locations are going to be based on those sediment range lines the Corps has done in previous years. And so by comparing those, you know, we'll be able to come up with some estimates of aggregation volumes and that kind of thing. I don't know that the scope of this project will, you know, report on that, but we'll be able to, you know, provide that data to the Corps, and I'm sure they would probably use that to come or assist in providing updated numbers of volumes and that kind of thing.
Can you conduct the aerial surveys during the winter, and how much does winter ice impact or change the movement of sediment annually?
So I wasn't planning, you can do surveys during the winter. I wasn't planning on doing any of that surveying during the winter. But yes, ice is, you know, a lot in several studies that I've looked into. You know, ice is a major geomorphic contributor. You know, even I work a lot on the Platte River down here in Nebraska, and you'll even notice if you get ice formed in the channel, there's lots of scour that goes on as the river's moving around the ice, and so it scours out a new channel in some instances. And so I know in the Niobrara that you know, when we get these years like 2019 where you have a lot of ice, there's a lot of erosion that occurs as that ice moves down. You know, just qualitatively, I don't know. I haven't done any quantitative analysis to figure out, you know, how much more or less that, you know, than a regular flood would be. But yes, we know that ice is a huge factor when it comes to erosional capabilities.
Mm-hmm. I think there is some information in the Spencer Dam report from the Dam Safety Organization just about ice in general. And
right, yeah.
I mean, it sounds like there's a need for more information as well. Just
Mm-hmm.
And we've had a few more questions here. How long will it take to get results from the core samples you plan to gather?
So like I said, I'm planning to collect data this year and next year. Each, generally, core sample results we get within 3 to 5 months. So if I collect data in August or September, I should have it by late winter, early spring for this year. And then, you know, we'll see what, so yeah, I guess the first year, yeah, would be early next year.
Okay. And maybe I asked Paul Boyd if he'd also join us if a question might come up that he could also speak to. There was a question, is the former reservoir area behind Spencer Dam continuing to deliver sediment to the downstream stretch of the river? Or is that something that you'll look at, or do we
That's
know?
not in the scope of this study, but just from uh, just experiences I've had in that area, I'm sure some of that sediment is moving its way downstream. I mean, if if we get another high event this year, that'll probably continue to pull or erode some of those sediments away. I know how that dam failed. It went through the levee side, so on the opposite side, then I guess it'd be the north side of the channel. Some of those sediments it'll probably take a while for those to get transferred downstream. It just depends on how the river moves. But the way it's set up now, I'm guessing some of that could be in storage for a long time.
Okay. Why don't we revisit exactly the area that you're looking at surveying or doing research on? And once again, this is basically a research for the National Park Service. Was that?
Correct. Yeah.
Okay. And the recreational river actually goes along the Niobrara River near the confluence, and then up to Standing Bear Bridge. Is that
right? Yeah, I probably should have spent another minute or so exactly showing where that went.
And I don't know if, like, I'm sure the objectives of your study, does it indicate what the Park Service is concerned about, or?
Yeah, so the main concern the Park Service has, oh wait. Okay, can you see my screen now again?
It's working on it. Yeah.
Okay, so this is the downstream end of the Park Service boundary. So yeah, here's Standing Bear Bridge. So it's just, let's see how far that is. It's not very, I know it's not very far.
Mm-hmm.
So about half a mile downstream of that bridge. And actually we actually did a study looking at how nutrients pass between these backwaters and the main channel. I know a lot of this area is really interesting habitat, so we might include a little bit of these backwaters over here. Might go just a little bit outside of the reach. What was your other? I'm trying to remember what your other question was.
Sure. And it does go, I guess, upstream all the way to Fort Randall Dam. Is that
right?
Okay.
Right. Well, yeah. It goes all the way upstream Fort Randall Dam. And I'm gonna look at some of the range lines from the 2019 survey to see, if some of these up here had some pretty substantial changes, even though they're not downstream of the Niobrara. They're still affected by the backwater and that kind of thing that, when the river rises, it all spreads out. So I could see us potentially going as far as this. I don't know if there's a name for this bend up here. Paul might know, but this would probably be as far upstream as we would look.
Okay. But the Park Service, they'd basically be interested in whether, like, pollution from the sediment might be impacting habitat, or habitat might be flooded, or.
So there are organic contaminants, especially there's pesticides that used to be used that are no longer legal, that this dam was in place for 100 years, so it's possible that there are some contaminants in that sediment that moved way downstream, and if they get released into the water over time, that's harmful to the invertebrates, and anytime you're getting interruptions to the food chain, that's not good. So so that's something we're going to be looking at.
Okay, and I suppose, if we had questions about what the Park Service might suggest or have ideas as to how to address that, we would want to address that to the Park Service probably.
Yeah. Mm-hmm.
Okay. Well, and I guess in that study area too, there are some other tributaries. Like you mentioned, by Chief Standing Bear Bridge is the Brazil, and then
Yeah, there's
we have the
Verdigris
Ponca.
Creek over here that's actually included as well.
Okay. Let's see. I guess there was a question about sediment buildup in the dechannelized Ponca Creek that is flooding in all directions. Comment on how this affects the wild and scenic river designation in this area. I guess, is that part of the designation of your whole study area?
I don't think Ponca Creek would be part of this. Yeah, I'm not really familiar with that area too much, to be honest. So.
Okay. Let's see. But I guess, it sounds like your research, because of the high impact of the flooding and the failure of the Spencer Dam, is what kind of created the basis for this research. I guess the other tributaries would have experienced flooding as well, but maybe since they don't have dams that were holding back this historic sediment, I guess, maybe it's a little bit different situation, but and I guess, will you be able to look at how sediment loads and volumes have changed and compare that with when the Spencer Dam was there and how it is now? Is that something that your research will be able to address?
Not this, it'll definitely help in assessing that. Outside of the scope of this specific project, I have hopes that this work might, drum up more work that we could look at that kind of thing. But the funds for this particular project would not be going to something like that specifically. But like I mentioned before, with just with the surveys and that kind of thing, it's going to provide data that others can use, or myself, hopefully, if we can get other projects started from this. So.
Okay. Maybe if you could just fill us in on, like, in that area, you mentioned a Verdell gauge. What kinds of data are you gathering just on a daily normal basis that might not be impacted by this study?
Okay. Yeah. So, for those that don't know, we have a gauge. It's called the Niobrara River gauge. I can show you guys where that is.
So that's actually on the Niobrara River.
Yeah, on the Niobrara River. So here's Verdell up here. So it's actually, way south from it, but this is actually within the National Scenic River Reach. And we have a stream gauge here. So it's monitoring the stream level. We also this year actually, through an agreement with the Park Service, through a different study, are monitoring water quality, so that that includes turbidity. You know, I mentioned that the LiDAR is only going to be flown if the turbidity is below a certain threshold. But so we'll have data to look at from that. And then it also is collecting dissolved oxygen data, conductance, and pH. Actually, yeah, I believe pH, water temperature for sure. And that data is publicly available through the USGS NWIS system. And for anybody who's interested in that, wants to know where that data is, I can send them a link. And then we have a stage only. So some of our gauges are stage only, where they're just looking at how, you know, the river level. The gauge at Riddell is a stream flow gauge too. So we do stream flow measurements to determine, based on stream level, what kind of stream flow and discharge or cubic feet per second. But at Niobrara, we have a gauge at this bridge now that's been fixed. And actually, we had a gauge there previously, and it was washed out during the flood, but it's been replaced. And then we also have I believe we have one on the Missouri River just to the north of Niobrara, but I believe it's also just a stage only gauge as well.
Mm-hmm. Will there be any public notice of when the radar plane may be out?
That's a good question. I can check with Brenda on that. I don't know what the normal protocol is. Obviously, it'll have to be okayed with the FAA and that kind of thing. I don't know if they have to put out a public statement, but for those I will if it goes on, I will definitely email you, and then you can send that out to all the MSAC, emails list, and so that everybody's aware that it's going to happen.
Okay. Let's see. I guess, do you have anywhere else to look to around the country for any, I guess, historical information or comparable information?
For as far as for Lewis and Clark specifically, or you?
Or just, I guess, this research of how an area is impacted after a dam failure and flooding.
I mean, I know of there's several. The one I can think of mainly, there's been studies done in Washington when a dam was removed intentionally, and so they knew it was going to happen ahead of time, and so they modeled what they expected to happen and then measured what actually happened. You know, that system is a lot different because it wasn't a sand bed stream, it was a gravel cobble stream, I believe. So I don't know of any that would be as analogous to Niobrara with just how sandy it is. I'm sure internationally there probably are. I don't know of any off the top of my head, but yeah.
Yeah. Okay. Well, I think we tried to address the questions that came in.
Yeah, and like I said, I'll make sure I get you my cell phone number, so if anybody wants to call and talk about this or other stuff.
Sure. Okay, and did you say there were some other groups or other agencies that are working with you on this?
Yeah, well, so the Park Service obviously will be working pretty closely with me. I'll be talking with Paul Boyd a lot about the survey data from last year, and determining. So another big part of this is, like I said, it's habitat related, and so the Army Corps of Engineers has a group that focuses on the terns and plovers. So I'll be talking to them a lot about where they're seeing nests and that kind of thing. What if there are certain areas that they are interested in. I had talked to, I believe, Mark Dixon last year, and so I need to follow up with him and see if there's ways that we can assist his research. And yeah.
Okay.
And I'll probably Fish and Wildlife Service. I'll be contacting them too.
Mm-hmm. Okay. Well, I think we maybe got some ideas on maybe some other groups we can invite for a upcoming webinar. Maybe the Park Service would be a good group to talk to see what the objectives are for their research here, and see how that might fit into some of the things that MSAC's concerned about as well.
Mm-hmm.
Let's see, I guess we'll follow up on a few of these things. And does anyone have anything else? We have a couple minutes here if you have anything. Let's see. I guess in relation to the gauges, maybe one last question here. Are there other gauges that USGS would like out there, but just haven't had the opportunity to put out, or?
I mean, it's always nice to have more gauges, especially when it comes to flood estimations and that kind of thing for the future. I don't know if there's any. It's tough in this area because there's not a lot of bridges, and it's. I mean, you can put in gauges that aren't on bridges, but it's a lot more expensive. Logistically, it's pretty challenging. So in this particular area, yeah, I don't know of any specific locations or anything like that, but if somebody is interested in a certain location, I can definitely have you talk to our data chief and see if he knows of a cooperator that might be interested. So.
Okay. I believe this webinar is being recorded. I did just get a message that the portal may have been keeping some people out for the first 20 minutes. So
Okay.
we will post this on our YouTube channel so everybody can see that if they missed it. And those gauges, are there some that continually measure kind of the rate of sediment, or is that not something that can be gauged?
So there are, we don't have any in Nebraska. Minnesota has some. So what it requires is, several years of data collection to, match up. Usually it's what's called an ADCP, which is basically pinging in the water, and you have to collect physical samples and match up or get a relationship between those two things. And so it takes a few years to develop that relationship. So it's still an estimate, but it gives you, and in a river like Niobrara, you have to have specific areas, because it's so wide and the channel moves around, it makes it tricky. But if you could find a specific pinch point where the sediments, coming in a smaller channel, that's definitely a possibility. But it's nothing that we have active in Nebraska. We've developed some relations between turbidity and sediment at some other streams in the state. And so we kind of have an estimate, but we don't, we're not providing that data on a continuous basis.
Okay. Okay, well, I think we'll just keep an eye on this, and we'll see what more we can learn from some of the other agencies as well. And it might even do our group some good just to learn more about the National Recreational River status and what that means, and how that fits into the whole river system. So, but we appreciate you joining us today, Nathan, and everyone else. And we appreciate the research that the USGS continues to do. And know a while back you addressed one of our annual meetings, and that was some interesting research in trying to see what potential uses there might be for some of that sediment. So we'll keep an eye on things like that and hope that there's some more funds out there someday to keep doing this research. So
yeah, thanks for having me. And like I said, if anybody wants to follow up, I will provide my contact info to Sandy and have her send that out. So
okay, thanks everybody.
everybody.
Yep.